Okay, Assalamualaikum warahmatullahi wabarakatuh. Let's start our first chapter. That is what we call basic concepts of electric circuits. What you're going to learn in this chapter is about charge, the current, voltage. This is what we call the basic element of the electric circuits, and what is actually power and energy, and the concept of AC and. So let's recall back. What is electric circuits? So in order for you to have a complete electric circuit, you need to be connected. So the keyword here is interconnection of electrical elements. What is element here means? If you look at this circuit, what is the element? The element here is the resistor, and also what we call here the integrated circuits. Electric circuits, you need to have a continuous path from one to another end. Once your path here is disconnected, means there is some broken loop in between, the circuit we call open circuit. So it's not a complete electric circuit. So why we need this continuous path? Because you need the charge to flow from one end to another end. So once the charge is flowing, you can get the current. Okay. So the keyword when talking about electric circuit, it need to be a continuous path and unbroken loop. See from here, what can you see from these circuits is the most basic one. There is the three elements here. We have a light bulb and the battery and the switch. And even it can go to the next one. There is a bit complex here. There is one circuit with the IC, and it can go to the more advanced one, the chip that is inside your laptop, in your computer, right? So the wire here is the one that is connected to one element to another. So let's move on the basic SI units. So I believe you have learned this before. So when you unit is very important. So you can just write 2, but what this 2 means? Is it 2 ampere or 2 volt or 2 coulomb? So the unit is the most important thing inside electric circuits to determine whether this is charge, voltage or current. Okay. So when talking about charge, the unit is coulomb. When talking about voltage, potential, there is voltage, resistance is ohms, and you will also learn about inductor and capacitor, where the unit is Henry and Farad. And what is power? Is the combination of the voltage and current, VI, and then you got the unit watt. So please make sure every time you derive or you solve any circuit analysis, please write the symbols and the units together. Okay. And you will see also this is the factor. So usually we'll go to this milli or kilo ohm. Okay. So how the circuit behaves? So the circuit behave like I mentioned before. You need to have all the elements connected using the wire. Elements, if you want to, for this chapter, that is very important. The first one is charge. We will always denote with Q. The second one is current, I, and the third one is voltage, V. So you're going to see the relation between charge towards the current and between current towards the voltage. Actually, charge. Charge is electrical property of the atomic particle which matter consists. So how you explain? When you are small, you like to play balloons, right? So when you rub the balloons together, it will create a charge. This charge is actually happen when you start to rub two balloons together, right? So the object with the same charge, so charge have polarity, so you have the same charge, it will repel. But once you have a opposite charge, it will attract together. So if you see this figure here, a positive charge attract a negative charge. Because it is the opposite polarity, it will attract. But when it is a negative polarity, it will repel. So that is the concept. This charge apply in the electricity. So if you look at these models, I know you learned chemistry before, right? So in one particle, you will have, in one atom, you have electron, you have proton, and you also have neutron. So in the round at this valence here, what we call electron. So electric charge is carried by either proton will have a positive charge, and electron it will have the negative charge. Okay, see here, what is the value of the charge? Okay, so when you're talking about electricity, so electricity means that the movement of the electrons, where the electron itself have a charge. So the fundamental charge of the electron is actually 1.6 times 10 power of minus 19 coulomb. Okay. The charge of one electron, when you're talking about electron, the charge is negative. But when you're talking about proton, the charge is positive. So means one electron will bring minus 1.602 times 10 power of minus 19 coulomb. That means that one electron will have minus 1.602 times 10 power of minus 19 coulomb of charge. So when talking about charge, you can't create. Charge can only move. So just now we say electric circuit have a continuous loop, right? From point A to point B. So the charge can only move from one to another. It cannot be destroyed. It cannot be created. It only can move from one to another. If this circuit is complete, there is a continuous path. Means the charge can be moved completely from A to B. That's what we call electric. Now you already understand what is charge. So charge you denote by Q, okay, and the unit is coulomb. One electron is 1 times 1 electron consists of 1.602 times 10 power of minus 19 coulomb. Then how this charge relate to the current? So what is current? Current means movement of the electric charge. Remember just now, charge cannot be created or cannot be destroyed. It can only move. So how the current happens? When your charge is moving from one to another in a wire over a period of time. Okay, so if you look at this formula here, how you relate? I is actually current, Q is actually charge. So this charge will move from one time to another time. So you're going to denote by time here. So I equal differentiation of Q over time. That's why we have the word movement of charge in a wire over a. So how you can define current? Current is the time rate. That's why you have d over dt. Time rate of what? Time rate of charge. This charge is the one that is moving, right? Movement of electric charge. So the change of the electric charge over the time, you can get what we call current. So what is the unit for the charge? That is coulomb. What is the unit for the time? That is second. So C over S, that is ampere. What we call the current. 1 ampere equal 1 coulomb over 1 second. Okay. So we have two type of current. What we call DC current. Second one, what we call AC current. So DC current, there is a direct current. It will not change over time. And AC, it will change over the time. What is the unit for current? Ampere. how you calculate the current is the movement of the charge over the time dq over dt. Now you can inverse the equation here. To find the q, you're going to integrate I equal dt plus the initial condition, and then you can have here initial time to the certain time. So this is how you integrate the equation for the charge to have the you are going to integrate the equation of the current to get the charge. Next, how is the direction? So the direction is between the we have positive ions and negative, right? So positive it will move accordingly, and how about the negative? It will be at the opposites. Let's move to voltage. So what is actually voltage? Voltage is, if you make an analogy here, you have a waterfall, right? So waterfall means you have from a high potential to a lower potential. So same with the voltage, you have what we call one high potential to the lower potential. There is a voltage drop between these two. So what is actually voltage? Voltage is what we call difference in energy level. If you see the figure here, when talking about voltage, usually we put a battery. So let's say this battery is 1.5 volt. So your battery have a polarity, right? Plus and minus, for example. So this is what we call, like the analogy of the waterfall just now. This is what we call high potential. This is the low potential. So now you're going to connect it a light bulb. So in order for you to have the charge moving from one to another, you need to insert what we call voltage. So this voltage will give you energy level from high to low. So the energy difference at this voltage will cause the charge to move from the positive towards the negative. That's why how the current. Let's see the formula. So if you recall just now, the current is I equal dq over dt. But now we are moving to the voltage. What is actually voltage? So voltage is the differentiation of the between the time here. What you're going to differentiate is the energy. The energy, we call this in joules, and the Q here is in coulomb. Okay, but how you're going to find the energy? You're going to just integrate this equation. So W equal integrate what? Integrate, this is V, right? Integrate V dq plus the initial condition. Okay, so when we have if VAB is more than 0, means what? So we have here A, here B, right? If VAB is greater than 0, means A is positive, B is negative. If this less, is the vice versa. So there are two concepts now. One is the charge. Okay, what is charge? Charge is inside the what is current? Current is the movement of the charge by the time. And what is the voltage? Voltage is the difference potential. So you have dW over the D charge. So let's see here, what is the voltage here is VAB. If VAB here is more than 0, means here is plus and okay. So let's see some analogy here. So if you see the analogy here, the voltage, what is voltage? Just now voltage is between two potential, right? Between high and low. So that's where you have this like a tank. The more pressure you put here, the higher the current. So how you can get the voltage? dW over dq. How you can get the current? When you supply the voltage, there will be the current. How the current works means that the charge will start to move. So once the charge start to move, you can get the current, that is I equal dq over dt. Okay, the last term that you will learn in this courses, there is resistor. Resistor is what is the diameter of this pipe. The bigger the pipe, the easier the current can flow. So the smaller the pipe here is a the current here is like the water here will have more difficult to flow, right? So resistor will control, we call here resistor will control the water or the current. The last concept, there is power. Now you have learned about I, you have learned about V. I equal dq over dt, the movement of charge over the time. V is the electric potential between high and low, means you are going to differentiate in terms of the Q, right? But now what is power? Power you need to measure by time. So power is almost the same like current. It's the time rate. So when talking about time rate, it means d over dt. But what you are going to differentiate here is the work. Is the energy by time. Just now the voltage is energy by the charge. Okay. So you have here power is the time rate of the expanding or absorbing energy over the time. So how you can combine this one together? dw over dq multiplied by dq over dt, they are the same, right? So this one is actually v, this one is actually I. That's why you get the final equation p equal to v. Last one. Now let's see the law of the conservation energy. Just now is the law of the conservation of charge. Charge cannot be destroyed, created, absorb equal to the power supply. Okay, so you can see here the law of the conservation energy is the supplied power is plus the absorbed power will be equal to 0. So what I'm going to highlight here is when it is a positive power, it actually absorb, but once you got a negative power, it actually supply. So the total of absorb and supply must be equal to 0. So now let's see what is the difference between positive and negative power, how you're going to calculate. Positive power means absorb, negative power means supply. So how you know this is positive or negative? Your current enter the positive terminal. For negative power, your current, the current have direction. Your current enter negative. So let's see this figure here. This is the polarity of your voltage. This is the direction of your current. Now, your current here enter towards the positive, so means your current is entering towards the positive, so the power here is positive. Now let's see what happened to the current here. Your current is entering the negative. When your current is entering the negative, it's a complete loop, right? When your current is entering the negative, it means supply, means your power here is negative. Your current here is entering the positive, means absorbing. Your current here is entering the negative, is supply power. Example here, when your current here, so what is the power here? Absorb or supply. So now your current here is entering the positive, means here is P equal VI, right? Entering positive means absorb. This one 12 watt. What happened to here? Your current here is entering the positive, so this one also 12 watt. So this is what we call absorb. What happened here? Your current here is entering the negative, so it become minus 12 watt. Your current here is entering the negative, that is negative 12 watt. So the total power absorbed and supply here is 12. And last one, how you get the energy W here from your power. So you know just now you know P equal dW over dt, right? So W equal is you integrate the P dt by T over 0. Last part is the active and passive. Here we have what we call active element, that is the one that generating energy, that is called battery and generator, right? The one that is passive element, it only can absorb, called R, L and C. So the one you show below here is active element. So you have this when it calls circle. This is what we call independent, where it not depend on anything. If you have a triangular or diamond shape here, this is what we call dependent. It depend on something. You will learn later. Okay. So if we define here is an independent voltage source. This is an independent current source with arrow is current, and here is a dependent current source. Here is the dependent voltage source. And these are passive elements. It can only absorb energy. That is called R and C. Chapter 1. So you learn about system unit. What is charge? What is current? Is the movement of charge over the time, right? What is the voltage? Voltage is the change of the charge of the energy, and your power is actually over the time you're going to see the energy either absorb or supply over the time. So we see in the next video on all the examples of chapter